Welcome. Let's take a look at some scientific notation problems, and you may want to be playing along with a calculator. I've got mine in my hand right with me because we're going to need that a little bit later on. So let's go. Okay, first it's important to know this. Scientific notation requires us to have one non-zero digit to the left of the decimal. So in this first problem, right now, my decimal located here ultimately has to move 1, 2, 3, 4, 5, 6 places to get there between the 6 and the 2. So 6 is our one non-zero digit to the left of the decimal. So I'm going to get 6.2, and moving the decimal is just by multiplying by powers of 10. So it is either 10 to the sixth or 10 to the negative sixth. And I see so many students get caught up in this trying to memorize a rule. Well, yeah, memorizing is great for the short term, but a week later you take a test, or 6 weeks later you take a semester exam, and we forget and we get every one of these wrong potentially because our memory doesn't serve us well. So this isn't a memorized rule. This is very, very simple to understand. I turned a tiny number into a bigger number. So if this 6.2 is bigger than this, I need to make this whole term smaller to equal that. Well, to make it smaller, I use a negative. 6.2 times 10 to the sixth would be a huge number. I need to make it become small. That simple. So number 2. There is no decimal. Well, of course there is. The decimal's over here to the left of the, or to the right of the last zero. I need one non-zero digit to the left of the decimal. 1, 2, 3, 4, 5, 6, 7. So that becomes 9.5 times 10 to either the seventh or the negative seventh. And I've seen teachers teach this by saying, well, when we move the decimal to the left, we use a positive or negative number, and you're just reinforcing problems that down the road for students here. We're going to take a moment and understand this. 9.5 compared to, what do we have here? 95 million is a small number. In order for this to equal this, 9.5 has to get a lot bigger, and it's not going to get bigger with a negative exponent. So this is 10 to the positive. Of course, you don't have to put the positive there, but 10 to the positive seventh. That's simple. That is a very easy rule to remember. In fact, I said that almost exactly wrong. It's not a rule we want to remember. It's a very easy rule to understand. Understanding will not fail us. Okay, so number 3, got a decimal here to the left of the 3. I need one non-zero digit to the left, so I move here. And I get 3.9, and I only move the digit or the decimal one place, so it's either positive 1 or negative 1. Well, 3.9 is bigger than 0.39. So I have to make this become smaller using a negative. Now, kind of a weird example, because this is not a number that typically we would write in scientific notation. Usually it's for really, really big numbers or really, really small numbers, numbers close to zero. It's really to save space oftentimes. Okay, next one. This again, and 200,000 isn't crazy big, but we'll go ahead and write that thing in scientific notation. Decimal moves from the back. 1, 2, 3, 4, 5 places, and we either get 2, which should be fine, or 2.0 if you prefer. Either of those would be fine, but we moved the decimal 5 places, so either 10 to the fifth or 10 to the negative fifth, but I'm not guessing. This is a rule, again, that makes sense. 2 is much smaller than 200,000, so I have to make this become a lot bigger. So it's 2 times 10 to the positive fifth. Or as I said, you could have 2.0 times 10 to the fifth. That is not to be confused with this being a fraction. Just two separate answers. Either one of these would be fine. Now let's see if we can get rid of this thing quickly today. Good. Okay, again, write each number in scientific notation, a little bit more of the same. Decimal moves 1, 2, 3. Sometimes people stop there, but I do not have one non-zero digit to the left yet, so one more space. 6 times 10 to the, I moved it 1, 2, 3, 4 places, so positive 4 or negative 4. But if I take 6 times 10 to the positive fourth, I'm going to get a bigger number. And I need it to be equal to a smaller number, negative 4. Isn't that simple? Number 6, decimals behind the 6. I have to move it 1, 2 places. 6.86 times 10 to the, I moved it 2 places. But 6.86 is smaller than 686. I need this to be bigger than 6.86, 10 to the positive second. Okay, and then we've got, here's where it really causes problems, because if you're trying to do 1 through 6 memorizing a rule, now you got to come up with a new rule for 7 and 8 and perhaps beyond, and that rule will be in kind of a conflict with your other. Okay, when I move one way, it's negative. When I move another way, it's positive. I'm just going to understand what's happening. I'm going to move the decimal 3 spaces. And because it's negative 3, I want 8 to become smaller. Well, if I move that this way 3 spaces, fill in with 0, I just made 8 become bigger. So I'm going to move the decimal from here, 1, 2, 3 spaces, fill with zeros, 0.008. Do we necessarily have to do the little underlining thing? You don't have to, but it's probably safer. I could start here and say, well, I got to move it 1, and then 2 more spaces for 3, creating 2 zeros. Maybe be a little cleaner, but I have no problem for the time being if we're putting the little underlines in. Okay. Number 8. Is my number going to, when I multiply by 10 to the 9th, going to get bigger or smaller? Well, it's going to get bigger. Which way do I move the decimal in order to make it bigger? I have to move it to the right. 1, 2, etc. 9 places. Well, my first move gets it to the right of 1. And I still have 8 more moves. So I have 8 more moves after I get to the right of 1. That's 8 more zeros. 1, 2, 3, 4, 5, 6, 7, 8. You can see over the course of this, I've moved the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9. So anytime we have a number this big, probably a good idea. See if I can get that off there. It took more away than I wanted. Let's go 1, 2, 3, 4, 5, 6, 7, 8 more zeros. Probably a good idea to go back in and put your commas. Oh, okay, now I see it's 7,100,000. Okay. More of those. This number is going to get smaller by 7 decimal places. So I'm going to give myself some room to move to the left. 276. I've moved it 1 place in front of the 2 by time I'm here, and I've got 6 more places to go. 1, let's get rid of that little decimal. So 1 place to the 2, 6 more. 1, 2, 3, 4, 5, 6. Let's see if that worked. I started here. 1, 2, 3, 4, 5, 6, 7 spaces. So that is it. Definitely a number we might prefer to refer to this way than to list out in standard form. And number 10, this number is going to get bigger. I don't memorize, okay, when I multiply by 10 to a positive, I move it to the right. I really don't have that memorized. I understand that when I multiply by a number by 10 to the third or by 10 to a positive, the number gets bigger. How does the number get bigger by moving the decimal? We move it to the right. So it was here before the 5. I move it 1, 2, 3 places, creating room for 2 zeros, 2,500. Okay. Likewise, number 11. 9.5 is going to get 3 decimal places bigger. By the time I move it behind the 5, I still have 2 more moves to make 2 more zeros, 9,500. Number 12. 7.96 is going to get 4 decimal spaces smaller. So by time I move the decimal in front of the 7, I still have 3 more moves to make. 1, 2, 3. Isn't that simple to remember? Don't you dare try to memorize that. Okay, a little bit different, and I mentioned earlier, here's where you're going to need a calculator. Here's what we're going to do with this. I'm going to use my calculator and divide these. And I'm going to round to 2 decimal places for the sake of brevity here. So 7.3 divided by 3.9, and I get rounded 1.87. Now I'm going for scientific notation here. I love the 1.87. I just need to know how many tens I have. Not divided by how many tens I have. I want to know how many tens I have. So I have to find a way to get these tens up to the top here. And the way I do that is to change the sign of the exponent. This becomes 10 to the negative fifth. Very often we're taking things like this from the top down to the bottom. So this, I refer to that as an elevator ride. If you have a negative exponent as a factor, you can move that to the denominator and make the exponent positive, but this is like a reverse elevator ride. I want everything in the top. So now I just say, how many tens do I have up top? Negative 8 and negative 5 times 10 to the negative 13th. That's my total number of tens in the numerator. Okay, similar, 14. The first thing I'm going to do is I'm going to take 3.3, my plain old number 3.3, times my plain old number 1.4. And if I needed, I'd round to 2 decimal places, but this actually is 4.62. I love 4.62. That is half of scientific notation. Now I just need to know how many tens I'm multiplying by. Negative 5 tens and 1 10 gives me a total of negative 4 tens. And we're done. We're not going to rewrite that because it wants the answer in scientific notation. A nice approach to this. Okay, and again, I'm going to let the 2 act on the 1.9 separately than the 2 acting on the 10 to the 4th. So that is 1.9 to the second. I'm going to do that one here. And that gives me 3.61. And then I'm going to let the 2 act on the 4. And I would say we have 2 groups of 4 tens. 2 groups of 4 is 8. And this guy is scientific notation. And we're thinking, hey, this is great. Not too bad at all. We just take the regular numbers, work with those. The tens work with those. Sometimes things get a little bit trickier. Negative number times negative number. So I've got 9 times 7.57, and that is 68. I'm just going calculator here, of course. 0.13. How many tens do I have? Negative 1 and negative 3. So times 10 to the negative 4th. And half of this looks like scientific notation. The other half, though, is not scientific notation. And wow, I see a lot of students mess this one up because they're like, well, I know I have to move the decimal 1, so that means 10 to the negative 4th is either going to become 10 to the negative 5th or 10 to the negative 3rd. I don't know which. Well, you don't know which because you don't understand what's going on. So let's understand and not try to memorize which way we move that exponent. This 68.3 is not in scientific notation. Let's put it by itself in scientific notation. Well, that would be 6.813. You could round that 6.81 depending on what the problem asks for. I'm going to leave it like that. And then I moved the decimal once, but is it positive 1 or negative 1? Well, this is back to a problem, the early problems. 6.83 is smaller than 68.13. So I need this to make it bigger so it matches this. Therefore, it is positive 1. So what do I end up with? A plain old 6.813. I have a 10 and negative 4 tens being multiplied together. So I end up with negative 3 tens, or 10 to the negative 3rd. Okay, Once again, scientific notation, not something to memorize, some things to understand. Okay, let's take a look at this one. I'm going to divide my regular old numbers. So here is 1.23 divided by 4. I'm going to round that to 2 decimal places. You don't have to. It is 0.3075, so I'm going to call it 0.31. I don't want tens in the bottom now. These guys are to the negative 8, so when they come up to the top, they become 10 to the positive 8. They're gone from here. So I have times 4 tens, 8 tens, 12 tens. Wonderful, scientific. Yikes, not scientific. So I got a little more work to do here. I have to move that decimal, 3.1, times 10 to I moved it once. We'll come back to that. That's being multiplied by 10 to the 12th. But should the exponent I used, should that be positive 1 or negative 1? Well, once again, 3.1, how does that compare to 0.31? This is bigger. So the times 10 has to, 10 to a power has to make this guy smaller by 1 place. So 3.1 times 10 to the negative first, 10 to the negative first adjusts to make 3.1 smaller, 0.31. So what do I end up with? A 3.1, a negative 1 negative 10 being multiplied by 12 positive 10s gives me 11 positive 10s, 10 to the 11th. Okay. Number 18, this is 7.4 to the first. 2 groups of 1 7.4s is 7.4 squared. Or 54.76 times 2 groups of 6 tens, 12 tens. Half of this is in scientific notation, but this half isn't. That would be 5.476. I moved the decimal 1 place, positive 1 or negative 1. Well, 5.46 needs some help in becoming 54.76. It needs to get bigger. So 10 to the positive first does that for us. Times, I've got another 12 tens here. 5.476, again, round at your pleasure. 10 to the first, 10 to the 12th, put them together. I've got 13 tens. So scientific notation, if you get caught up memorizing steps, I really think you're headed for a potential disaster down the road. Let's understand scientific notation. Thanks. Hope that's helpful, and stay tuned.